All right, we're going to continue with integration by parts. This is the second lesson. I'm just going to go through two examples. Okay, first one is easier. The second one is a little bit more involved, but I need you to stay with me. Don't forget to check out the quiz that I post with every video that I do. It's in the description and the pinned comments. Check it out. Make sure you do that either as a practice or after you've done your practice and you want to check your understanding and mastery. Let's get into it. All right, here it is. We're going to find the integral of x sine x dx. We're going to use integration by part. And as a reminder, the last lesson, the integration by part rule was that the integral of u dv is equal to uv minus integral of v du. All right, now in this one, very simply, we have to decide which is u, which is dv. And remember, you always want to make it simpler, not harder. Okay, so in here, we say u is equal to x, therefore du is equal to dx, dv is equal to sine of x dx, and the v, the integral of sine of x, is negative cos of x. Excellent. Now we're going to go ahead and we're going to set up uv, which is right here. So u is x, v is negative cos x, and then minus the integral of v, again, negative cos x, and du is dx, which is right there. Excellent. Now we're going to polish that. That's negative x cos x. Negative and negative, that's positive. And the integral of cos x, that's sine x. And then plus c. This is your final answer. Okay? Simple as that. Now let's look at another question. This is a new question. We're going to find the integral of x cubed e to the x squared dx. So stay with me. This is a little bit involved, but before we use this formula for the integration by part, we need to actually set this up so that we can use this. All right. So the first thing is that I'm going to break this x cubed up to x squared times x times e to the x squared. And the reason I'm doing this is because I want you to see that there's x squared here and the e has the exponent of x squared, and that can become useful. And every time you have a situation like this, to break it up, it will help you to see the pattern. Okay? So what does that mean? Once we have this, that's dx, then we say, let's suppose t is equal to x squared. And what is dt? Well, dt is 2x dx. Okay, look, we have an x here and dx there. Do you see that? We don't have 2x dx, but we have x dx. But that's not bad at all. So in this case, we can actually solve for x dx, which will become dt divided by 2 equal to x dx, which is right up there, okay? So now our new integral is integral of t e to the t dt divided by 2, because we just replaced x dx by dt over 2. Fantastic. Now, to make it a little bit simpler, I'm going to move that 1/2 to the front, rewrite, and I have 1/2 the integral of t e to the t dt. That's what we're going to do the integration now. Okay, now we're going to go through and we're going to do the integral by parts. What is u? It's ubt, because that's simple. Therefore, du is equal to dt. And what is dv? dv is e to the t, and therefore v is equal to e to the t. The integral of e to the t is e to the t. Remember that one, okay? All right, now we're going to go ahead and use this. u dv, the integral of u dv equal to uv minus integral of v du, t times e to the t minus the integral of v, which is e to the t, times du, which is dt. That's what we have. there is a half in front, make sure we put the half in front of it. So that I don't make a mistake, I'm going to put it in a square bracket. We're going to put a half in front. Excellent. All right. Now, leave the half alone if you want to, and then let's do the integration, and that's easy. And that would be 1/2 t e to the t minus the integral of e to the t is just e to the t, and then plus c. And at this point now, you're going to go back and remember, t was x squared. All right? This is the original one right here. This is what we had. T was equal to x squared. Now we're going to replace that and then rewrite 1/2 times x squared e to the x squared minus e to the x squared plus c. We can technically go ahead and simplify this more. You can actually factor out e to the x squared. You can factor that out. But this is the final answer to it. And notice what has happened. We went through the integration by part, but before doing that, we had to set this up so that we can make it and use integration by part. And whenever you have a setup like this, you may have to do some substitution at first to make it easier. And when you do that, then you're going to go ahead and then do the integration by part. All right. Okay, let's look at another example. Integral of x squared e to the x. That's what we're going to find. This is going to be an interesting one. Stay with me. So let's go ahead and then find the components. So let u be, this time we're going to do x squared. So du is equal to 2x dx, and dv is equal to e to the x, and v is equal to e to the x as well. Okay, very nice. We're just going to go ahead and now we're going to use the formula, and that is uv. So that would be x squared e to the x minus the integral of v du, e to the x, and du is 2x dx. Excellent. All right, we're going to polish that. That becomes x squared e to the x minus 2. I'm going to take the 2 out. The integral of x e to the x dx. Now, you look at this and you say, okay, well, this new integral, x times e to the x dx, it is still complicated, but it's a little bit easier than the original one. Perfect. So we just used integration by part the first round. Now, guess what? We're going to do it again. All right. Now, we're going to leave the first part alone. We're going to leave that part alone. We're just going to deal with the second part, which is this part right there. Okay. So let's deal with that. So the integral of x e to the x dx, that's what we're going to deal with. And we're going to use integration by part again. And we're going to put them all back at the very end. All right. Let's do it again. So we're going to do u equal to x again. Du is equal to dx. dv is equal to e to the x, and v, the integral of that, is e to the x. So now what do we have? We have uv. So here it is. We have x, and v is e to the x, minus the integral of v du, and v again is e to the x, du is dx. And look, this is easy now. We can deal with that. So let's rewrite x e to the x minus e to the x plus c. Okay? Simple as that. This was the second part. Okay, let's go back up. This is just this part right here. That's what we just calculated. Now we're going to bring the original part, which is the beginning part of this down. By the way, there's a 2 in front of it, so we could actually put a 2 in here to make it just simpler. Let's put the 2, and then we're going to include x squared, e to the x, and all of that. So we have final answer, x squared e to the x minus 2 times, open bracket, x e to the x minus e to the x plus c. Okay, and then now once we have that, we can either expand it or leave it be, but let's expand it and just see what we get. X squared e to the x minus 2x e to the x plus 2 times e to the x minus 2c, but really it doesn't matter. You can just call that c, and here it is. This is the final answer for this integral. We did use the integral by part twice. All right, go back to the question, make sure you look at every step, and don't forget to take the quiz at the end. It's in the description below or in the pinned comment. Okay, until next time.